Okay, welcome back to part 2 of mass spectroscopy. In part 1, we saw how we make the mass spectrum, the 5 steps required. Now let's analyze a sample. Now this is methanol. This is the mass spectrum that you would get. So just to remind ourselves that methanol looks like this. Okay. Now methanol weighs 32 grams per mole. And this is why we see a peak at 32. Okay. This in mass spectroscopy is called the molecular ion peak. Okay. So this peak has been detected because this ion has gone all the way through to the detector. Okay. So in IB, you can write this down as in this formula. Okay. You could also write CH3OH. Now, you will notice that there's a little peak at 33. And this is due to the fact that 1% of carbons is actually carbon 13. So if our sample contains carbon 13, which it will to some extent, you will have a mass of 33 grams per mole instead. So you see this little peak. Now, the rest of the peaks that you see are because when you gain a positive one charge, when methanol gains that charge, it is unstable and it actually breaks down. And those pieces that it breaks down to, we call fragments. Okay, so there's a very big peak at 31. And this just means that the compound has lost one hydrogen. And we detect this piece, this fragment, CH3O, of course, with a positive one charge. And the bigger the molecule gets, the more of these peaks we will see. We will also see a peak at 15, and this is due to CH3, the loss of CH3. Okay. Now, in the IB, you have a data booklet that you can use in the exam, and these are just some common fragments that are lost and the mass to charge ratio that you will find them in the graph. Okay, now let's analyze another sample. Okay, propanone has this formula. So propanone is a ketone. There's a double bond between the carbon and the oxygen. And overall, this weighs 58 grams per mole. And this is why we see the peak at this position. Okay. And this is the molecular ion peak. And as we talked about before, we will see a very, very small peak right above at 59 because of the carbon 13 isotopes. Okay, so C3, H6O plus 1. Now, if you lose a CH3 group, this fragment falls off. Now the mass becomes 43. And that's why we get the peak, which is actually even higher in intensity than the previous one. So we get C2H3O plus at 43. And again, we see this peak at 15, which is due to a CH3 fragment. Now, the higher the peak is, the more stable that fragment is because it's been able to get through all the way to the detector. Okay, so it's been counted more times. Now, if you want to see one more analysis, you can watch part 3 of this video where we'll analyze one more sample.